Hi class, we need to take a look at the next section which deals with, well, it's actually called the addition rule, and it's simply just a continuation of basic probability. And this is the basic idea. So in this portion of the section, we're actually going to look at compound events. Now, compound events are defined as events of the following form. You technically have two or more simple events. And one of the main formulas that we're going to be analyzing is the union of two events. Now, if they're asking us to evaluate the union, you're first going to evaluate the probability that one event occurs plus the probability of the second one occurs. But then technically you have to look at this section here, and you have to make sure that you're not overcounting that specific actual event. So that gets adjusted by subtracting the intersection of both of the events. So none of the events that you're going to be evaluating should go or should exceed 100% or the value of 1, since it's out of like all the possibilities or the sample space. Now, there's going to be events where technically this portion here, it's not going to actually have an intersection. So you're looking at those type of events, well, mutually exclusive. They cannot occur at the same time. So this portion here is referred to where both events can occur at the same time, but it's possible that both events cannot occur at the same time there. Now, the wording is a little bit confusing on some of these events. You're looking at rules of complements, and basically you're going to view it as follows. The probability that the event occurs plus the probability that doesn't occur, it's actually equal to 1 or 100%. Now, depending on how they're actually viewing it, some of the problems may actually be wording it as 100%. And then depending on what they're asking, some problems they're going to basically ask for the probability of the event not occurring, which is technically 1 minus the event occurring, or the event occurring is 1 minus the event not occurring. And all of these formulas basically get explained in this Venn diagram. You technically have the outer box to be all the possibilities or the sample space. This inner portion is technically the probability that the event will occur, and the outside portion is not occurring. Both of occurring and not occurring is equal to 1, or this one represents your 100% of occurrences. Okay, so let's take a look at a couple of problems. And this, this addition to the idea of evaluating probabilities, it's a little bit confusing because of what they're asking. Some of the events are not going to ask for the event occurring, they're asking for the complement. Now, you're going to basically follow the following idea. You're always going to declare the event. So in this case, they're talking about females. So let A equal to a female. And in this case, we're actually declaring the event, well, a female having the color blindness. Okay, so we're actually given in the problem what P of A is. That is technically this portion here. And we have to be careful because that's 0.25%. So not 25%, it's actually a 0.25. So it's actually really, really small. As a decimal, this is 0.25 over the values of 100. So that is what we have on that particular one. That's 0.25% or 0.25 over 100. We'll punch it in as a decimal in a minute once we evaluate the event. Now, what the problem is actually asking is not what's the probability that a female is going to be colorblind, but what's the probability that they're not going to be colorblind. So in this case, I'm just going to go directly to the complement. And this is 1 minus the probability of A. Now, the formula that I'm actually using here, oops. It's actually one of these three. So these are the formulas that I'm using. In this case, the problem is giving you the probability that the event is going to occur. We want the probability of the event not occurring. So this is technically 1 minus 0.25 over 100. Please plug it in so we can see if we can compare values. And I'm getting that this is 0.9975. Since we already declared A, we don't need to restate it. It's already understood that that's the probability of the individual is not colorblind. Let me double check. Once you punch this one into the calculator, you have to be very careful because it's 0.25 divided by 100. Okay, let's take a look at the second problem. And in this case, they're also asking the complement of an event. And this one is based on data. So the main event on this one is getting arrested. So I'm just going to say let A, and this is equal to getting arrested. Now you're given the probability of A, and in this case, this is 10 divided by 500. So that's the probability of A. They're asking not getting arrested. So in this case, this is the probability of, well, the complement, or 1 minus the probability of A. So 1 minus 10 over 500. Okay, I'm getting that this is exactly 0.98. Once again, you don't have to rewrite it as a sentence because we technically already defined what A is. So please take a look. 1 minus 10 over 500. I'm getting that that's approximately 0.98. Unless they mention anything about expressing that as a percentage, 0.88 would be perfectly fine. Let's take a look at example 3. And let me see. In this case, the event is, well, to believe that that it is morally wrong not to report all income on tax returns. So that's actually the event. So we're going to say let A equal to believe that it is wrong not to report all, I'm just going to write it as taxes. Actually, it's income on taxes. Sorry. All income on taxes. Now, the probability of A, it's technically 79%, or 79 over 100, or 0.79. Careful on this one. The previous one was 0.%. So this is just basically 0.79. And what they're asking on this one as well is what's the probability that the subject does not have that belief. So in this case, this is the probability of A not occurring, or 1 minus the probability of A, or 1 minus 0.79. And I'm getting that this is 0.21. So I need you to be a little bit careful on this one, because the way that the probability is given is a 79%, which technically is equal to 79 over 100, and not confuse it with the very first one, which technically was 0.25%. So this one is way smaller than, well, the 79%.